All right, today we are going on an incredible journey. We're going to follow a single web request from the moment you click a link to the second a page pops up on your screen. And along the way, we're going to break down 10 of the core concepts that make the whole modern internet tick. Let's dive in.
It all starts with something you do 1,000 times a day. You click a link and poof, in less than half a second, a whole web page is right there. It feels instantaneous, almost like magic. But what is really going on in that fraction of a second? That's the mystery we're about to unravel.
Well, here's the secret. It's not magic at all. What you're actually witnessing is this incredibly fast and intricate conversation. A little back and forth between your computer and some other powerful computer, maybe thousands of miles away. And that conversation, that dialogue, is the fundamental story of how the web works. Now, to understand any story, you've got to meet the main characters first, right? In our digital drama, those characters are the client and the server. They are the two sides of this whole conversation.
The roles here are actually pretty simple. The client, that's just your web browser, like Chrome or Safari, is the one doing the asking. It says, hey, can I please see this web page? The server, on the other hand, is that powerful computer whose job is to listen for that question, find all the right information, and then send it back. This simple ask and answer model, client and server, is the bedrock of the entire internet.
So, if the client and server are talking, what language do they speak? Well, they use something called HTTP. You can think of it as the official grammar of the web. It's a standard set of rules that make sure every request and every response is understood. And that REST part? That's like a style guide that works with HTTP, organizing the conversation into logical actions, like getting some data or posting some new info. The bottom line is, these two things make sure any client anywhere in the world can talk to any server.
Okay, so we've got our two characters, and we know the language they're speaking. But how does the message itself get ready for its trip? I mean, you can't just throw raw data onto the internet. It has to be packaged up neatly for the journey. And that packaging process is called data serialization. The packing the suitcase analogy here is perfect. It takes complicated data, like, say, all the bits and pieces of your user profile, and neatly folds it all into a simple, lightweight string of text. This makes the whole data package super small and tidy, which is exactly what you want for a lightning-fast trip across the web.
And just like that, our neatly packed request has arrived at the server. So now we get to peek behind the curtain and see what happens inside the brain of the operation.
Before the server does a single thing, it has to deal with security. And this comes down to two steps that people mix up all the time: authentication and authorization. Authentication is all about proving who you are. It's like showing your ID card. But authorization is about what you're allowed to do now that we know who you are. Does your key card actually open this specific door? It's a really crucial difference for keeping things secure. Now, here's a funny thing about HTTP, that language of the web. It's naturally stateless. That means every single request is treated like a brand new conversation with a total stranger. So, how does a website remember you from one page to the next? The answer is something called state. You can think of it as the server's short-term memory. It's the only reason items stay in your shopping cart while you browse. Honestly, without state, the web would be pretty much unusable.
A server also needs a rulebook that can change depending on the context. That's its environment configuration. So when developers are busy building and testing new features, the server is in development mode. But when you visit the live website, it switches over to production mode, which has much stricter rules for performance and security. This is also where the server keeps its most sensitive secrets, like API keys, safely tucked away from the main code. So the server has done all its work. It's figured out who you are, what you're allowed to see, and it's gathered up all the data. Now it sends the response back to your browser for the final act, the grand reveal.
Your browser doesn't get a picture of the web page. It gets code. The real magic happens in a four-step process we call the rendering pipeline. First, the browser parses the HTML to understand the skeleton of the page. Then, it combines that structure with all the visual styles, the CSS, to build a render tree. After that, it has to calculate the exact size and position of every single button, image, and line of text in the layout phase. And finally, it paints the actual pixels onto your screen, bringing the page to life. And it does all of this in milliseconds. It's wild.
Okay, so we followed one request from start to finish. But now, let's zoom out. Let's look at the big picture principles that architects use to make sure this whole system works reliably, not just for you, but for millions of users at once. These are the rules of the road.
A huge one is this idea called separation of concerns. It sounds complicated, but it's really simple. Every part of the system should have one specific job and do it well. The part of the code that talks to the database should not also be in charge of making a button look pretty. By keeping every part focused, the entire system becomes way easier to build, to update, and to fix when something goes wrong.
To manage all this complexity, developers rely on a concept that's perfectly captured by this classic quote. Abstraction is basically the art of hiding complexity. It lets a developer use a really powerful tool without needing to understand every single detail of how it works on the inside. It's like driving a car without needing to be a mechanic. Abstraction is what lets us stand on each other's shoulders to build bigger and better things.
Another key principle is all about one thing: speed. And that's where caching comes in. See, if a server has to go fetch the exact same information over and over and over again, things get really slow. Caching is the solution. It's like a librarian keeping the most popular books right there at the front desk instead of running to the back of the library every single time. It makes everything dramatically faster.
But this leads to a pretty logical question, doesn't it? If caching is so great for speed, why don't we just cache everything? All the time, forever? I mean, what's the downside?
And this brings us to a fundamental concept in pretty much all of engineering: trade-offs. The benefit of caching is obvious: incredible speed. But the risk is that your users might see stale, outdated data. A cached news article isn't going to show you the latest breaking update. This is the constant balancing act for web architects: how to maximize speed without sacrificing accuracy. And there's no single right answer. It's always a trade-off.
And so our journey is complete. We've seen how one simple click kicks off this complex conversation, a conversation governed by rules, security checks, and some really brilliant design principles. So the next time you open your favorite app or browse a website, just take a second to think about that incredible invisible architecture that's powering it all. What trade-offs are its creators making right now to bring that experience to you?